What is going on, guys? Welcome back to another Java video. In this video we're going to be talking about chapter 5, making decisions. Real quick before we hop into chapter 5 though, I just want to take this time to kind of talk about quiz 1. I know a lot of y'all did really well on quiz 1, so to those people who are really happy with their grades, good job and keep up the good work. But I know there's some people who didn't really do as well as they would want to on quiz 1, so to those people I would just say use quiz 1 as kind of a reality check to kind of show you how hard this class actually is and how much work you actually need to be putting into this class. Now you know how to study for the quizzes, and so hopefully you do better on quiz 2. A lot of people have talked to me about whether they should drop the class or not after quiz 1. To that, I say that if you didn't do as well as you'd want to on quiz 1, it's definitely still redeemable even if you got a poor grade. I know people who've gotten like 40s or 50s on their first quiz and have still bounced back to making like a high B or something, or almost making an A in the class. One thing I would say is definitely work on your daily grades. If you can maintain a pretty good daily grade average, then that'll really help you out in the long term. So, looking forward, if you're not happy with your quiz 1 grade, don't go ahead and drop the class or anything. It's still, you definitely still have a chance to make up for it. You have to do really well on your exam, and typically the exams people think are easier than the quizzes, so do really well on the exams. Kill the second quiz because now you know how to study for the quizzes, and definitely keep up with those daily grades. So if you guys can do those three things, I definitely think it's still doable to get a good grade in this class, despite what you may have gotten in the first quiz. So with that said, we can just hop into chapter 5. Now, in my opinion, chapter 5 onwards is kind of where Java as a class gets a little bit more exciting, a little bit more fun, as Java can get. But the reason why I say that is because from now on you're going to be building programs that actually have like these complex decision-making procedures behind them. Before, the programs that you were making were like really linear, like do this or calculate this or display that. But now you're actually creating programs that are, more exciting, because now these programs are thinking like human beings. They're actually going to be making decisions, and then based on these check conditions, they'll execute different things. So I think, from here on outwards, Java gets a little bit more fun. It's not as complex, so you'll see what I mean as we get into it. So let's just hop into this chapter. So, like I said, from here on outwards, we're going to be kind of creating programs that have decision-making logic behind them. So the program is going to, evaluate some kind of condition, and then it'll execute the program based on the decision that the program made. So in order to do that, we have to plan out how we're going to go about our decision-making. So these are ways that you plan out your decision-making logic. So the first one is called pseudocode. So what pseudocode is just planning out a program's logic by writing English sentences. So, if you want the program to do something, you just write out the steps in English, and so that as a programmer, you can see what the program is doing without actually reading code. So that's what pseudocode is. The second way of kind of planning out decision-making logic is using flowcharts. You're going to be seeing a lot of flowcharts in this chapter, and that's just one way of planning out different steps to do certain things. So, like it says here, there's steps in diagram forms, and so a flowchart just kind of maps out the decision-making steps through the use of diagrams. So the first thing we'll look at is flowcharts. So flowcharts use shapes to kind of represent what's going on in the decision-making process. So if you see a rectangle in a flowchart, know that a rectangle is an unconditional step. So it's just a step that you have to take in order to reach your desired output. And a diamond in a flowchart is a decision-making step. So once you get to a diamond in a flowchart, it'll either say true, do this, or if it's false, do something else. So that's what a diamond represents in a flowchart. So let's go ahead and look at some flowchart examples. So this is an example of like a sequential flowchart that kind of tells someone how to get somewhere. So it just kind of just telling someone directions to get to a certain place. So as you see here, there's a bunch of these boxes here, and each one of these boxes just has directions, and they're all in rectangles because they're all unconditional steps. In order to get to your final destination, you can't skip any of these steps, so these are all just unconditional steps. But let's say we introduce a decision-making structure. So if we're still showing someone how to get somewhere, what if we throw some decision-making structures in there? So we can make them choose between different courses of action. So that's what it says here. You can create decision-making structures and make the user choose between alternative courses on action, and that's based on some kind of value. And these values are either going to be true or false. So they're Boolean values. So if this check condition or this decisional condition evaluates to be true, the program is going to do one thing. If it evaluates to be false, the program is going to do something else. So that's the check condition that's being used in these flowcharts. So let's look at an example of that. So this example is the same one that we just looked at. We have these unconditional steps here that are just telling the user, these are the steps you have to follow in order to get to your destination. But now we have a diamond, and that's asking the user a question. So this question says, is the expressway backed up? So based on the decision there, it'll tell the user to do something different. So if it is backed up and you say yes, you'll follow this flowchart. If it's not backed up and you say no, then you'll follow that flowchart. So you can kind of see how you have these unconditional steps, and then along the way you have these decisional checkpoints that'll kind of change the course of action of your flowchart in order to get the same desired output, but just in different ways based on the decision and different values that you give to the program. And so the way that actually looks in programming, specifically in Java, is through the use of if statements. So an if statement is a statement used to make a decision. So in the same way that we saw in the flowchart, if the expressway was backed up, then they go a different route. If the expressway is not backed up, you take a completely separate route. So in that kind of sense, an if statement, if you're to apply it to programming, would do the same thing. If some kind of conditional check is true, it'll tell you to do something, or else it'll tell you to do something else. And the way you actually create that check condition is through the use of Boolean expressions, and that's going to be in the parentheses of an if statement. And we'll look at what the syntax looks like later on, but that's just a conceptual view of what an if statement is. And then inside of the parentheses, in the Boolean expression, you can use this double equal sign to determine equivalency. So if something is equal to something else, then you would run the code. If it's not, then you do something else. So that's kind of what an if statement is. It's the same thing as the flowchart, but kind of translated into code, and that's the way Java reads our program, is through the use of these if statements in order to indicate these decisional structures. So to kind of put it into perspective in terms of a flowchart and looking at code here, so this is our if statement. So it says if your quiz score is equal to 10, then you print out the statement that says the score is perfect, right? So if it does this and that check is true, then you print out the score is perfect. So if we see how that looks on the flowchart, so we have this decisional structure here, in this diamond, and it says, is this quiz score equal to 10? And if it evaluates to be true, then you print out this statement here that says the score is perfect. So that's kind of how we translate that flowchart into code. Also, one thing to note here is that you never put semicolons at the end of if statements here, so that's what this diagram is telling you not to do. It says don't put a semicolon at the end of the if statement, because if you put a semicolon at the end of an if statement, it's going to stop running right there, and it won't evaluate the lines under it as a check condition. So kind of the way it looks in a diagram form is what it says here. So whether it's true or false doesn't matter, because it's going to run the output regardless, because you ended the if statement. You ended the if statement without giving it a chance to run output based on the condition. You specified the condition, but you never specified what to run after the condition because you ended it with a semicolon. So just never put a semicolon at the end of an if statement. Make sure you actually have the output under the check condition. Another thing to note is that don't use a single equal sign here instead of a double equal sign. So whenever you're trying to do if quiz score is equal to 10, you have to do a double equal sign in that case, because a double equal sign is what actually represents equivalency, whereas a single equal sign is used for assignment. So if you remember back to creating variables and declaring certain values to certain variables, you would use a single equal sign, like if it was the variable my age. So it would be like int my age is equal to 20. We use the equal sign in that situation to show assignment of a value to a certain variable, whereas now we're using the double equal sign to determine equivalencies. So if you actually want to set something equal to something else and kind of evaluate that condition, then you have to use the double equal sign. So make sure you're using the double equal sign, not the single one. And so what this slide is saying is that you can't use equal signs to refer to objects because objects aren't variables, so you can't use a double equal sign or a not equal equivalency operator to determine whether objects are equal to each other or whether strings are equal to each other, because keep in mind, strings are not primitive data types. A string is just a class that exists within Java. So you can't use a double equal sign to compare string values, and you can't use a double equal sign to compare object values. When you're doing this, it won't give you an error in Java, but it's not going to be doing what you think it's doing. It's actually just comparing memory location, or memory address in this case. So that's what the slide is saying here, is that whenever you use a double equal sign to refer to an object or a string, it's not actually comparing the values of those objects or strings, but rather it's comparing the memory addresses of the objects or strings. So all you have to know from this slide is that don't use the double equal sign to compare strings or objects. And so now we've seen what an if statement is, but an if statement only indicates one kind of action. So as it says here, an if statement has only one action, and that's a true action. So if something is true, then you're going to do a certain action. But what if something evaluates to be false? And so if something evaluates to be false, that's when you can use an if-else statement. So an if-else statement has the luxury of having multiple actions, is what it says here. So if something evaluates to true, you can still do that action, but if it also evaluates to false, you can carry out a completely separate action, is what it's saying here. So if-else statements are used whenever you want to indicate multiple actions, whereas if you just want to indicate one singular action that the program's going to take, you can just use a singular if statement, but typically you're going to be using if-else statements. So what it's saying here is that whenever you use the keyword if and you're using the keyword else, you have to vertically align them whenever you're coding them to indicate that they kind of go together. And it's also saying here that it's illegal to use else without an if, right? It wouldn't make sense to have an else statement without an if statement. So anytime you have the word else, you also have to have the word if somewhere in your program to kind of indicate the flip side of the coin there, because they kind of work simultaneously. And then the last thing it says here is that you can have curly braces. So I prefer to write my if statements with curly braces because it kind of just keeps everything in scope. But some people also write their if statements or else statements without curly braces. And we'll see examples of what that actually means. Because on the exam, they'll have some examples with curly braces and without curly braces to kind of confuse you and kind of ask you whether something's in scope or not. So just kind of understand that if statements can have curly braces or they can be written without curly braces. But if you don't include curly braces, then that changes the scope of what exists inside of an if statement. And we'll look at examples of that later on. So in this diagram here is kind of similar to what we looked at earlier, right? So we have our if statement here, which is the conditional check of whether the quiz score is equal to 10, and if it is equal to 10, then you print out the score is perfect. But what if their score is not equal to 10? What if someone inputs like a 5 or a 6 as their quiz score? Then you can print out no, it's not, that the score, to indicate that the score is not perfect. So the if statement here, the conditional check right here is that, is the quiz score equal to 10? And if it's true, then you follow that line of logic and you print out the fact that the score is perfect. But if it evaluates to false, then you follow the line of logic on the left side and you print out the statement that says, no, it's not. So that's just kind of a way to put the if-else statements into a diagram to kind of make it easier to see what's going on. But that's just kind of the general syntax of how to write an if-else statement, and that diagram is just showing you the logic behind the if and else statement. And so this is just another example of another if statement, but what I think is important here and what I want everyone to take note of is the fact that in this if statement they use curly braces here. So you typically use curly braces whenever you have multiple lines in your if statement. So in this case, they're indicating someone's regular pay and their overtime pay. They're calculating it. And so there's 2 lines of code in the if statement. So if you have multiple lines of code in your if statement, you're going to want to use a curly brace. So if we go back to the example up here of the quiz score, there's only one line of code that follows the if statement, right? So it says if quiz score is equal to 10, then print out something, else print out something else. So there's only one print statement after the if statement, whereas in this case, there's multiple lines of code that exist after the if statement. So if there's multiple lines of code, you're going to want to use a curly brace to indicate what's in scope of the if statement. So scope is still kind of important, especially when you're doing like if statements and loops and stuff like that. So scope is going to be something that's important throughout the entire course. And so to kind of give you guys a better example of scope and how it functions with if statement, let's look at an example here. So here I wrote two different if statements, kind of similar to the ones that we just looked at about quiz score, right? So in this first if statement here, I said if the score is equal to 10, you're going to print out, I wanted to print out two things, right? I wanted to print out the word woohoo, and you did great. But one thing to note is that if you're not using curly braces with an if statement, it's always only going to evaluate the first statement right after the if statement. So in this case, the if statement, the only thing that it's going to read is this first line here, because I didn't indicate any curly braces, and so when I don't indicate curly braces for an if statement, it's only going to read the line right after the if statement as part of the if statement. So by not putting curly braces, this is kind of what it looks like. This is how Java reads it. By not putting curly braces, it's implying that you only want this statement within the scope of the if statement. So anytime you don't put curly braces for an if statement, it's only going to read the first line after the if statement. So this is kind of what's implied when I don't put curly braces, right? So it's only going to read this statement here, and then it's going to print this out regardless of the if statement. This if statement on line 8 just kind of exists outside of the if statement. So when you don't put curly braces, it's only going to print out the first line. But in the second example here, where I actually do set up curly braces for my if statement, it's going to print out both lines based on the if statement conditional check, right? So if someone puts in a score of 8 or 9, then it's not going to print out either of these. Whereas if someone puts a score of 8 or 9 into the first if statement here, it's not going to print out this first line, but it's still going to print out the second line regardless, because this second line exists outside of the scope of the if statement. So it's just like another print statement that just exists there. That's going to get printed every single time regardless of whether the condition is true or false. So this is one important thing to note. So this is how they'll try to trip you up on the exam. They'll give you examples of things that might be in scope of an if statement or of a loop or something. And so it's your job to recognize what actually exists within inside the scope of the if statement or the loop or something. And if it's not inside scope, you're going to have to know what's actually happening, what's going to be printed out, how many times something is going to be printed out. So definitely keep scope in mind when you're dealing with if statements and loops. So we've already kind of looked at decisional making steps using check conditions inside of if and else statements. But what if you want to have multiple conditions that you want the statement to check? And so if you have multiple things that you want to include as check conditions, then you can use what are called and or logical operators. So this allows you to include multiple conditional checks inside of your if statement. You want the condition to be true if it is true for this and this, or if it's true for this and something else. So if those two conditions evaluate to be true, then run the program. So the first thing we're going to talk about is an AND operator. So in an AND operator, it's used between two boolean expressions, and then both of those expressions must evaluate as true before the action and statement can occur. So what that means is that whenever you use an AND operator, both conditions have to be true in order for the program to run. So the whole conditional check here has to evaluate as true. So the first check has to be true, and the second check has to be true if you're using an AND operator. And so the way you actually indicate an AND operator in Java is by using two ampersands. So these two AND signs here are called ampersands, and to actually write that in code, you use those two ampersands to indicate an AND operator. And one other important thing to note here is that Java runs on what is called a short circuit operation. Now what a short circuit operation means is that the expressions on each side of the logical operator are evaluated only as far as necessary. So to kind of explain what that means is that Java won't do extra work if it doesn't have to. So like I said, in an AND check condition, if you're using an AND operator, then both conditions have to be true, right? In order for the entire program to run. So if Java evaluates the first condition to be false, it won't even look at the second condition, because it doesn't matter if the second condition is true or not. The first condition is already false, so the entire Boolean expression is going to be false. So Java only evaluates conditions as far as it has to. And the same kind of holds true for an OR logical operator. For the OR operator, if part of it is true, then it won't even look at the other part of it, because a part of it is already true, so it'll just go ahead and evaluate the entire Boolean expression as true. So we've talked about the AND operator, so now we'll touch on the OR operator. It kind of functions the same way as AND, but it has a couple of differences. So like we said, it's used between two Boolean expressions, and at least one of the expressions has to evaluate as true before action in the statement can occur. So what that means is that for an AND operator, both of the conditions have to be true in order for the entire Boolean expression to be true. However, for the OR operator, only one of the conditions has to be true in order for the entire statement to actually take action, or for the program to run a certain action. And so the syntax for an OR operator is two pipes here. So AND operator is two ampersands, OR operator is the two pipes. So if you don't know where that is, I think for most people it's above your enter key on your keyboard. So those two pipes there, you use those to indicate an OR operator. So now we'll just look at some examples of using AND operators and OR operators in code. So in this example here, now we'll just look at some examples of actually using AND operators and using OR operators. So in this case, this is an example of using an AND operator. So in this code here, there's a nested if statement. So we'll talk more about nested if statements later on in this chapter, but for now, just know that nested if statements are just if statements that exist inside of if statements, and that just means that both of those conditions have to be true in order to get your desired result. So in this case, the first check condition in the first if statement is that if items sold are greater than minimum items, then you go to the next step. And the next step here, the second condition, is that total value has to be greater than min value. And if both of those conditions are true, then you can reassign sales bonus to bonus, right? So that's just a couple nested if statements, but you can do this more efficiently using an AND operator. So in this case, you want both of these test conditions to be true, so why not just put that in an AND operator? So the first test condition here is the same one as the one up there, and then we have our double ampersands indicating and then we have our second test condition. So what the statement is saying is that if items sold is greater than minimum items, and total value is greater than minimum value, then assign sales bonus to bonus. So those two lines of code are doing the exact same thing, but the second one is just a little bit more efficient because you're using the double ampersand to indicate the word and it's a little bit more legible too. It makes more sense to when you read it out loud. So these are just examples of actually using the AND operator and what it looks like. So similar to the AND operator example, this is an example of using the OR operator. So in this case, we have a couple if-else statements. So in the first if statement, it says, if items bought is greater than minimum items, then assign discount rate to discount. Else, if items value is greater than minimum value, then assign discount rate to discount. So there's a couple of different conditions here that are being met. So in order to be more efficient, you can just take those test conditions and put them in an OR statement. So if you're saying if items bought are greater than minimum items, or if items value is greater than minimum value, then do the final condition here, or reassign discount to discount rate. So just different ways you can write things, and you can be more efficient if you use the OR operator in this case. And so now we've talked about if and else statements, so we arrive at something called switch statements here. Now switch statements, you're not going to be using them as much as if and else statements, if at all, but I know they'll probably be on your exam, so definitely just be familiar with switch statements, but just know that you're not going to be using them as much as if and else statements. So what a switch statement is that it's kind of an alternative to a series of nested if statements. So like we said earlier, a nested if statement just means writing an if statement within an if statement. So whenever you have a series of if statements within each other, those are just nested if statements. So that's just kind of to give you an idea of what nested if statements are. So switch statements are an alternative for using nested if statements, and what switch statements actually do is that they test a single variable against a series of other values. So we'll look at an example of what switch statements actually look like later on. But before we look at an example, we have to kind of go over what are some of the keywords that exist within inside of a switch statement. So the word switch actually indicates that you're starting a switch statement. It starts the structure, and then it's followed by an operation inside the parentheses, kind of like the check condition. And then you have the word case in switch statements, and the word case just kind of indicates the values of each thing you're trying to check. And then after that, you have the word break, and what break indicates is that whenever you want to single the end of a certain case, you have the word break there. And then finally, you have the word default, and using the word default is completely optional, and then it's used prior to an action that should occur if the test variable does not match any case. So if none of the cases are actually matched, then you just set a default value, and if you have no matches in your cases, then it'll just pick the default value. So I know this is a little bit confusing, but hopefully when we look at an example, you'll see how each one of these words actually functions in a switch statement. And so this is an example of a nested if statement, right? And like we said, switch statements are alternatives to nested if statements. So we'll look at an example here of if-else statements that are nested within one another, and then we'll see how you can translate this to a switch statement. So in this case, we say if someone's year is equal to 1, then print out the word freshman for them. If it's 2, print out the word sophomore, so on and so forth. And then if they don't enter any of those, then we print out the word invalid year. So that's pretty simple to see, right? It says if this is equal to this, then print out this. And you just keep going down that chain of logic. But you can also do this in terms of a switch statement. So to kind of initiate the switch statement structure here, you have the word switch up here, and then within the parentheses, you have the condition that you're checking for. So in this case, we're checking each person's year. And the values for the year are actually written here, right next to the word case. So case is kind of like an example. So in this case, the first one says case 1. So if year is equal to 1, then we print out the word freshman. And then if case is equal to 2, then we print out the word sophomore, and so on and so forth. So in the same way that the if-else statement functions, switch statements do the exact same thing. So if it's equal to 1, then you print out freshman. If year is equal to 2, then you print out sophomore. And then each case just indicates every single year. And then obviously if they don't input any of that stuff, then we can set a default here, and then the default is that they set an invalid year for us, and we can't evaluate that. Another important thing to note is that there's a break statement here. There's a break statement under each case. So what break statements do is that it means that once you find a match, so let's say the user inputs the year 1, and then the year 1 becomes freshman, then the break statement says don't go any further, don't look at any of the statements after this, just break here and stop the program. Don't read anything after this break statement. So this break statement here indicates that Java isn't going to read any of the code after it. So it's saying break, we found our answer, let's just cut it off here, we've got our answer, and we're done. So that's kind of what a break statement does and how it functions. So it's important to note what break statements do, because there might be an example on your exam where they'll have a break statement or they won't have a break statement, and then it's up to you to kind of know what the program is doing and what code Java is actually reading depending on where the break statement is. So the break statement just kind of tells Java, hey, once I see the word break, I'm going to stop reading any code that comes after it. And so this is just another example of a switch statement. So, you have the word switch up here to kind of indicate that you're starting the switch statement. In this case, we're trying to figure out what day some user is inputting. So our test condition is written as day here in the parentheses, and if day is equal to Monday, you're going to print something out. If it's equal to Tuesday, Wednesday, Thursday, whatever the case may be, and then you indicate that by having the word case, and every time something is equal to the word Monday or Tuesday, then it'll print out the appropriate statements here. So this is just another example of what a switch statement looks like. And so kind of like I talked about earlier, in switch statements, you have to have the word break if you don't want Java to read all the code in your switch statement. So it says here, if break statements are omitted, then all statements within the switch statement execute from that point forward. So if you don't want Java to execute every single line of code in your switch statement, you're going to want to have to include breaks at the end of each one of your cases. So that's just kind of the functionality of what the word break does in a switch statement. So this is an example of an instance where someone didn't put breaks in their cases. So if we look at case 1 or case 2 here, there's no break statement. Our first break statement doesn't come until we enter case 3. And so the reason for this is that a supervisor could be in charge of multiple departments. So right here it says, the condition you're checking for is the word department. So whether they're in department 1, 2, or 3, the supervisor is always going to be Jones. So it doesn't matter where you put the break, because if they enter 1, 2, or 3, it's going to automatically go down to Jones, and it's not going to break there. So if I inputted the word 1, it'll be Jones. If I inputted the number 2, it'll still be Jones. If I put the number 3, it'll still be Jones. Whereas if I put the number 4, it'll be Staples, and then it'll stop there because I have a break statement there. So that's just kind of understanding what a break statement does. And sometimes there's uses for not putting break statements. Like in this case, one supervisor is in charge of multiple departments, so you don't need a break statement for all the departments he's in charge of. So this is just an example of when you don't include break statements. And so one other thing that you guys should be familiar with is called conditional operators. And what conditional operators are is that they're just an abbreviated versions of if and else statements. So if something is this, give it this value, or else give it another value. So using conditional operators, it functions the same kind of way. So the syntax for that is in this example here. So you have a test expression, and then based on that test expression, same way, in an if statement, you have a test expression. If it evaluates to be true, then you have the true result, and if it's false, then you have the false result here. So there's a question mark here, and then there's a semicolon. So the true statement goes after the question mark, and so the false statement goes after the colon there. And so in this example here, we have an integer declared here called smaller num, and then we want to assign smaller num a value. And so the test condition here is if A is less than B, then the value is A. If it's false, then the value is B. In this case, we actually give a value to these variables A and B right here. So what it's saying, so A is equal to 2 and B is equal to 3. So what it's saying is if 2 is less than 3, then the value of smaller num is A. If it's false, then the value of smaller num is B. So in this case, we're actually trying to figure out what the value of smaller num actually is. So the test condition is A is less than B, and in this case 2 is less than 3, and so we go with the true condition here, and the true condition would be after the question mark. So the value of smaller num would be A, which is equal to 2. And if that's kind of confusing, maybe pause the video there and try to recognize what's actually going on in this scenario of this conditional operator. So there's always going to be your test expression, in this case A is less than B, and then if that condition is true, then it's going to be the value that comes after the question mark, and if the result is false, then the value is going to be whatever comes after the colon. So that is what a conditional operator does in a nutshell. So one other thing that we have to talk about is what is called the not operator. So we've shown how you can show equivalency between things, but now you can negate that by using the not operator. And so the actual syntax for it is that it's written as an exclamation point, and it negates any boolean expression. So anything that evaluates to be true becomes false. Anything that evaluates to become false is actually turned into something that's true. So there's a couple examples down here. So in the first example here, we have this check condition that says age has to be greater than or equal to 25. Well, in this case, age is set equal to 21, and obviously 21 is not greater than 25, so that test condition would be false. But in this case, we have a not operator. We have a little exclamation point here. So age greater than 25 would be false because 21 is not greater than 25, but that not operator would flip that. So this test condition would actually evaluate to be true. So even though 21 is less than 25, the not operator switches the Boolean expression and turns it into something that would be true. So you can use a not operator to indicate something that's not equal to something else, or to flip a Boolean expression. So there's another example down here that you guys can look at. I'm not going to go over it. And so now the last thing that we're going to talk about is operator precedence. And so what that means is that you can use as many and operators or operators as you want to, but just know that there's a certain method that Java uses to evaluate and actually read these operators. So and operators are always going to be evaluated before or operators. So and operators have precedence over or operators. So Java is always going to read and operators first, and it's going to read or operators second. One other thing to note is that statements in parentheses are always evaluated first. So to kind of just look at an example of what that means exactly is that we have this test condition here, right? So we have 3 different conditional checks. Traffic tickets have to be greater than 2, or the age has to be less than 25, and gender has to be equal to male. So what Java does is that it reads the and operator first. So it's going to read this right here. So it's going to do this check first, and then it's going to do this conditional check second, because it's always going to read the and operator first. So it's going to verify whether gender is male and they're less than 25, and then it'll go to the traffic tickets and do that conditional check. So it's always going to read the and operator first. But in the second example here, if you actually put a parentheses with these 2 conditional checks, then Java will evaluate the parentheses first and the and operator second. And so in this case, it'll evaluate whatever's inside the parentheses first, because you actually have the parentheses to indicate you want Java to evaluate that first, and then it'll evaluate the and operator check second, because the parentheses takes precedence over the and operator. Whereas in the example above, it'll evaluate this part first and this part second, because the and operator takes precedence. And so that covers all the conceptual stuff from chapter 5. And so now we'll just kind of look at some examples of if and else statements to kind of give you guys a better example of how to actually write them and what they look like in code. And so this is the first example we're going to look at. First, we'll start with just dissecting if and else statements. And then in the second example that we look at, we'll actually code an if-else kind of program. So real quick, I would say pause the video, try to figure out what this program is doing and what actually is being displayed. So I'll just go ahead and tell you that this program is a program that is asking the user whether they want pine, oak, or mahogany for their furniture or something. And then based on whatever they enter, it'll tell them pine is it costs a certain amount of money, or oak costs a certain amount of money. So based on the choice that they entered. So in this case, pause the video, try to figure out what this program is doing, and then we'll dissect it in just a second. So to kind of explain what this program is doing, we'll just start at the very top. And so, obviously we have our class, we called it furniture, and then we opened up our main method. And then within the main method, we have 3 different variables here, right? So our first variable is a string, the second one is an int that holds a value of price, and the third one is like the user's choice. And so in our first variable we have called type, we initialize it to an empty string here, because whenever you declare a string, you have to give it an initial value. So in this case, it's just an empty string. There's nothing that exists inside of it, but we have to initialize it. So that's what that's doing. And then we have a variable called price, because we know that this program is going to be telling the user first a certain type of furniture, and the second thing is going to tell them is the price of that certain type of furniture. And then the third thing here, this variable called choice, is when we're actually asking the user what furniture they want, right? So we're taking, we're asking the user a question using the show input dialog, and then we're saying choose 1 for pine, 2 for oak, or 3 for mahogany. So based on whatever they enter, we've parsed it, and then we've stored it in this integer value. And then the reason why we actually have to parse this here is because you need it to be as an integer value in order to do these conditional checks. So if you want to do choice is equal to 1 or choice is equal to 2, you have to store it as an integer, because remember we said in the slides that you can't compare string values using the double equal sign. So that's why we actually end up parsing it. And then so now we have this variable called choice that holds the user's choice. And then we get into the actual, meat of the program, like what this program is actually doing. And so based on these if statements and the conditional checks, it'll tell the user what type they want and then how much that price is for whatever type they entered. So let's say the user enters 1, then we have an if statement here that says if choice is equal to 1, then the type is pine, and the price is 100. And then it does this exact same thing for 2 and 3. So if choice is equal to 2 or if choice is equal to 3, then the type is oak or the type is mahogany, and then we set the price for each one as well. So that's just how an if statement looks in a program. That's how you're going to be setting it up, and then you put whatever you want inside of it. At the very end, we're just going to be displaying whatever the user inputted. So let's say they put in 1, so it'll say a pine table costs $100 or something. So it'll just take whatever the user inputted and then print it out back to him to show him what he chose and the final price of the product that he chose. So that's a super simple program. Maybe if you don't quite get it, pause the video and try to understand what is going on here. But now that we kind of looked at what this program looks like and how to actually write if statements, we'll go ahead and code it for ourselves. So in this example, we'll actually be creating a program using if-else statements based on the instructions we have here. So the instructions say, create a program that tells the user about their IQ score. If a user scores higher than 100, then their score is above average. If a user scores 100, their score is average. If a user scores under 100, their score is below average. And then it says, if a user inputs a score that is less than 0 or greater than 200, then display an error message. So those instructions are pretty straightforward. We're just creating a program that checks a user's IQ, and then based on wherever they scored, we'll display a certain message to them saying their score was above average, average, or below average. And then also, if they enter something that's not in scope, if it's less than 0 or greater than 200, we'll display an error message. So let's go ahead and get this started. So the first thing we have to do is that we know we're going to be asking the user a question. So I'm going to go ahead and write my import statement up here. So import javax .swing.j option pane, and then so we have our import statement. And then the second thing we want to do is declare a class. So I'll just go ahead and call it public class IQ. After that, we have our main method. So we'll go ahead and write our main method here. So once we've written our main method, we know that the stuff that we're actually trying to do is going to go inside of our main method. So the first thing we have to figure out is how many variables we're going to have in this program. So to me, it seems like we're only going to have one variable, and that is the user's score. So, it doesn't seem like we're going to have anything else just from reading these instructions here. And that score is something that we're actually going to be getting from the user. So, and we know it has to be an integer because we're going to have to do conditional checks with it later. And so, we can just go ahead and declare an integer. We'll call it score. And we want to set it equal to whatever the user tells us. So I can parse it and everything and do all of that in one line. So I'll do integer.parseInt, and then within the parentheses, I'll actually ask the user the question. So I'll say joptionPane.show input dialog, and then the first condition is always going to be null, and then we'll ask the user, what is your IQ score? So the user is going to tell us their IQ score, and then based on that information, we're going to display certain things to the user. So now that we've gotten their IQ score, we have to set up our conditional checks. So if we just follow along, in the instructions, it tells us exactly what to set up and how to set it up. So I'm actually going to start at the end here. So the last thing it tells me is to set up an error message. And usually when you have error messages, I like doing that first because it just makes it easier when you're writing the program. So I'll start at the last line here, and it says, display an error message if a user inputs a score that is less than 0 or greater than 200. So I'll say if they input a score, so if score is less than 0 or, right, you have your two pipes there to indicate the word or. So if score is less than 0 or if score is greater than 200, then we want to display some kind of error message. So like I said, I like using curly braces inside my if statement. So we'll open up our curly brace here, and we'll just say system.out.print. We'll say, error. Oops, put in quotes here. So we'll say error, your score is out of range. So if a user enters a score that is greater than 200 or less than 0, we'll just display some kind of error message to them. And so the reason why I actually like doing the error message first is because it's kind of like a check mark, like a tollway. You have to pass this in order to do the rest of the program. So right off the bat, I'm asking the user, if their score is less than 0 or greater than 100, then you're out of range. But if you're within range, then we'll actually go ahead and carry out the rest of the program. So in this case, if they do pass this first little conditional check up here, then we can write the rest of our program and do the rest of our checks. So if that's true, and if it's not true, right, if their score is in range, then we can start doing our other if statements. So we write our else statement here. And then remember, the else statement has to be in line with the if statement. So our else statements are in line. We'll go ahead and open up our else statement here. And then within the else statement, now we can actually write our conditional checks, the if statements of, is their score actually higher than 100 or is it less than 100, right? So you pass the first check of whether it's in range or not. And then you can get to do the check of whether your score evaluates to be average, above average, or below average. So the first thing it says is that if a user's score is higher than 100, their score is above average. So if score is greater than 100, then we'll go ahead and display that their score is above average. So you say your IQ is above average. So that was pretty simple. So we can write our next if statement. And remember, these are all nested if statements that exist within the overarching one that does the conditional check to see whether their score is in range or not. So the second one says if their score is equal to 100, then you just display that that's IQ is average. So we'll say your IQ is average if you score 100. And the last thing it says is that if score is less than 100, then your score is below average. So we can just write another display here and say your IQ is below average because they scored under 100. And so it looks like we're done here. So we'll go ahead and save it and run it to see whether this works or not. And so I know it's really tiny here, but what it says here, it says, what is your IQ score? So let's say we enter 100 as our IQ score, hit OK, and it'll display that your IQ is average because it ran through the conditional check. It bypassed this first check here because obviously we put something that was in range. So it bypassed the first check, went straight to the else statement, found 100, and then printed out the statement that, correlated with the score of 100. But let's say we run it again, and then let's do a score that's out of range. So let's say someone inputs 250. Obviously 250 isn't possible because the highest IQ score is 200. So we hit enter here, and then it gives us an error. It says, error, your score is out of range. So it started up here at the first check, and then it realized that, hey, you're not even passing this first conditional check, so I'll go ahead and tell you this error and say that your score is out of range. So Java doesn't even run the else statement. It doesn't even evaluate these statements down here because it didn't even pass the first conditional check. So think of it whenever you're writing these nested if statements as just check marks. So it has to pass the first one, then the second one in order to get to the lower tiers of the if statements. So one thing I would say is that, if this is making sense to you, then maybe, pause the video and then try to recreate this program without looking at this code again. So see if you can do this yourself without actually looking back at this code to see if, you're actually learning this material. Pause it whenever I just had the instructions up here, read the instructions and try to translate those instructions into code and see if you get it right and see how well you actually do, just to kind of, evaluate where you are. And so that's going to do it for this video. Hopefully this was helpful. Stay tuned for the next video. The next video we're going to be going over loops and stuff like that. So just as exciting as if and else statements. So I'll see you guys in the next video. See ya.